Welcome back to Click Future, where your future is a click away. This is the 7th episode in our Quantum Horizon series, where we explore the fascinating intersections of AI, quantum computing, and space achievements. What if everything you think is real, the screen you're watching, the chair you're sitting in, even your own body, is actually an elaborate simulation? What if our entire universe is running on something like a vastly powerful quantum computer? This idea, known as the simulation hypothesis, has moved from science fiction to serious scientific debate. And as our own simulation technologies advance, from virtual reality to quantum computing, the question becomes increasingly compelling. Tech leaders like Elon Musk have suggested the odds are 1 billion to 1 that we're living in base reality rather than a simulation. Scientists like Neil deGrasse Tyson put the chances at 50-50. The idea isn't entirely new. Over 2,000 years ago, Plato's allegory of the cave suggested that what we perceive as reality might be merely shadows of a deeper truth. Today, we're exploring whether that deeper truth might be computational in nature. The modern simulation hypothesis was formalized in 2003 by philosopher Nick Bostrom of Oxford University. His argument goes like this. Bostrom proposed that at least one of these 3 propositions must be true. First, civilizations like ours typically go extinct before reaching technological maturity. Second, advanced civilizations are not interested in running simulations of their evolutionary history. Or third, we are almost certainly living in a simulation. The logic is straightforward. If civilizations can reach a level of technology where they can create detailed simulations of conscious beings, what Bostrom calls ancestor simulations, they would likely create many such simulations. If that's the case, simulated minds would vastly outnumber real minds, making it statistically likely that we are among the simulated. This argument gains strength as our own computing power grows exponentially. In just decades, we've gone from simple video games to immersive virtual reality and increasingly sophisticated simulations of physical systems. As Bostrom puts it, if we don't think we're currently living in a computer simulation, we are not entitled to believe that we will have descendants who will run lots of such simulations of their forebearers. Today's most advanced simulations can model everything from weather systems to the early universe, from protein folding to neural activity. While still far from simulating conscious experience, the trajectory is clear. When you look at the rate of advancement in computing power, AI, and simulation technology, it's not hard to imagine that a civilization a few hundred or thousand years more advanced than ours could simulate conscious experiences indistinguishable from reality. If our universe is a simulation, what kind of computer could run it? This is where quantum computing enters the picture. Our universe appears to be fundamentally quantum mechanical at its smallest scales. Simulating quantum systems accurately on classical computers is extraordinarily difficult. The computational resources required grow exponentially with the size of the system being simulated. This challenge led physicist Richard Feynman to propose the idea of quantum computers in the 1980s. His insight was that to efficiently simulate quantum systems, you need a computer that itself operates according to quantum principles. As Feynman famously put it, nature isn't classical, and if you want to make a simulation of nature, you'd better make it quantum mechanical. Today's quantum computers, while still in their early stages, have already demonstrated the ability to simulate quantum systems that would be intractable for classical computers. As quantum computing advances, these simulations will become increasingly sophisticated. This raises an intriguing possibility. If advanced civilizations developed powerful quantum computers, they could create simulations that accurately reproduce the quantum mechanical nature of our reality. And those simulated realities could potentially develop their own quantum computers and nested simulations. The mathematics of quantum mechanics is essentially describing information and how it evolves. It's not a huge leap to wonder if that information is being processed by something analogous to what we would call a quantum computer. Is there any way to scientifically test whether we're living in a simulation? Several scientists have proposed potential approaches. Physicists have suggested that a simulated universe would need computational shortcuts to manage limited resources, similar to how video games only render what the player can see. These shortcuts might create detectable glitches or patterns in cosmic rays or the distribution of energy in the universe. Others point to the Planck length and Planck time, the smallest measurable distance and time interval in our universe, as potential evidence of pixelization or discretization that would be necessary in a simulation. In 2017, researchers at the University of Washington proposed that certain asymmetries in cosmic rays could indicate we're living in a simulation with finite computing resources. While their initial analysis didn't find such asymmetries, more sensitive tests are being developed. Another approach involves looking for computational patterns in the laws of physics themselves. If our universe is optimized for computational efficiency rather than physical elegance, that might be detectable in the fine structure of physical laws. I discovered that certain equations in string theory contain error-correcting codes, the same codes used to make sure data isn't corrupted when transmitted. This doesn't prove we're in a simulation, but it's certainly suggestive that our reality has a digital aspect to it. Perhaps the most promising area to look for evidence is in quantum gravity, the as-yet undiscovered theory that would unite quantum mechanics and general relativity. Some physicists suggest that inconsistencies or unexpected patterns in quantum gravity might reveal the computational nature of our reality. Beyond the scientific questions, the simulation hypothesis raises profound philosophical and existential questions. These questions aren't entirely new. In the 17th century, philosopher René Descartes considered whether an evil demon might be deceiving him about the nature of reality. His famous conclusion, "I think, therefore I am," established that while he could doubt the external world, he couldn't doubt his own existence as a thinking entity. Modern philosophers have updated this with the brain in a vat thought experiment. If your brain were removed from your body and connected to a computer that perfectly simulated all your sensory experiences, how would you know the difference? Some philosophers argue that even if we are in a simulation, it doesn't fundamentally change the meaning or value of our experiences. Our joys, sorrows, relationships, and achievements would still be real to us. Even if we're in a simulation, this is still our reality. A virtual apple is still an apple in the virtual world. Virtual pain still hurts. Virtual love is still love. Others note the parallels between the simulation hypothesis and various religious and spiritual traditions. The idea that our physical reality is a projection or creation of a higher intelligence has echoes in many belief systems. The simulation hypothesis also raises ethical questions about our own development of simulations. If we create increasingly realistic simulations populated by conscious entities, what responsibilities would we have toward them? And if we are in a simulation, what ethical obligations might our simulators have toward us? If we're in a simulation, we might hope our simulators are ethical beings who care about our well-being. Perhaps we should extend the same consideration to any conscious simulations we might create. If we are living in a simulation, how should that change how we live our lives? Elon Musk has suggested that the simulation hypothesis should give us hope. If civilization stops advancing, that may be due to some calamitous event that erases civilization. So maybe we should be hopeful this is a simulation, because otherwise we are going to create simulations indistinguishable from reality where civilization ceases to exist. Some find the idea disturbing, that our reality might be artificial, our experiences merely data in some vast computer. Others find it fascinating or even liberating, suggesting it might explain strange aspects of quantum mechanics or consciousness. Most scientists and philosophers agree that even if we are in a simulation, the scientific method remains our best tool for understanding the rules of our reality, whether those rules are natural or programmed. Whether we're in a real universe or a simulated one, the laws of physics still apply consistently within our reference frame. Science is about modeling those consistent patterns regardless of their ultimate origin. Einstein once remarked, "Reality is merely an illusion, albeit a very persistent one." Perhaps he was more right than he knew. The simulation hypothesis stands at a fascinating intersection of computer science, quantum physics, and philosophy. While we can't yet prove or disprove whether we're living in a simulation, the question itself has stimulated valuable thinking about the nature of reality, consciousness, and computation. As our own simulation technologies advance, particularly quantum computing, we may gain new insights into this profound question. And perhaps someday, we might create our own simulations sophisticated enough to spark the same questions in their simulated inhabitants. Whether our reality is base reality or a simulation, the quest to understand it remains one of humanity's greatest adventures. And that quest continues regardless of whether we're made of atoms or bits. If you found this exploration of the simulation hypothesis fascinating, please hit that subscribe button to join us on this journey through the technological frontiers shaping our future. And leave a comment below. Do you think we're living in a simulation? And how would it change your perspective if we were? In our next episode, we'll explore quantum supremacy, the milestone when quantum computers surpass the capabilities of classical computers. Until then, this has been Click Future, where your future is a click away.